ladies and gentlemen. You know what the great thing about me recording these ahead of time is? It's Monday morning. You guys are tired. You guys are dragging probably. Hey, look around at me. I probably am too. But right now, I'm recording this Friday right after lunch when I just had a whole bunch of caffeine, so look out. Here we go. This one is the most complex version of doing the same thing we've been doing this whole chapter. Alright, this whole chapter is about solving the quadratic equation, graphing the resultant parabola, things of that nature. You can factor. You can complete the square. The problem is, sometimes completing the square leads us to fractions, which I know you guys aren't a big fan of, and not everything factors nicely. This is the, let's call it the messiest of all of the solutions. However, it's the only one that always works cleanly in every situation. So if you hated everything up until now this chapter, but today makes total sense to you, you're golden, because you can always just use the quadratic formula to solve. You can always use the quadratic formula. Now, if you're interested in how we get from the quadratic equation to the quadratic formula, I highly suggest you pause now and go watch my bonus video called the quadratic proof, not poof, that's a little different, but the quadratic proof, and that'll show you how we get from this step to this step. But for now, all you need to know is if you have a quadratic equation, in other words, something that has an x squared term, and you get it so that it's set equal to 0, you can solve for your zeros, the two values of x that get 0, by simply using this formula. But what are a, b, and c? They're the coefficients of x squared, x, and then the constant, respectively. Okay, so let's take an example problem. Let's say we had 2x squared plus 3x plus 4. I would look at that and I would say, well, 2x squared is not a perfect square, so completing the square would be difficult. I'd first have to divide every term by 2. Then I'd have x squared, and the middle term would be 3/2. And now to complete the square, I have to take half of 3/2, which is 3/4. Then I'd have to square that. That number is 9/16, or I think that's where we're at right there. Yeah, 9/16. And that doesn't sound like math that you guys would totally enjoy. Math that you would totally enjoy is the quadratic formula at that point. All right? So a is 2, if you look at it. A is positive 2. Right? B is positive 3, and C, the constant term, is positive 4. And if we simply take those values and plug them in to the quadratic formula, we will have ourselves an answer after a little bit of reducing or simplifying. So we say negative whatever my B term is, which is 3, plus or minus the square root of b squared, okay, so I'm going to take that number 3 and I'm going to square it, minus 4 times a times c. My a number was 2, my c number was 4. All of that over 2 times a. Now, that's a lot to remember. It's an absolute lot to remember. When I used to teach this class, heck, when I used to be in this class, there was a fancy way they had you remember it. And yeah, it can be pretty grippingly annoying. But what's great about grippingly annoying things is they're easy to remember. So yeah, back in the day, maybe I'd have all of you chorally sing until we all sang it together really embarrassingly. It'd be a lot of fun. It would go like this. You know the old song, Pop Goes the Weasel? Where, well, a lot of people remember this formula by singing it to Pop Goes the Weasel. It sounds a little bit like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, feel free to rewind that and listen to me sing that. Heck, put it on a loop. Have it lull you to sleep at night. But I have a better solution for reality. Hey, if you're going on to math analysis, calculus, if that is your math pathway, yeah, you need to memorize this at some point. Not all of us are in that boat, and I'm a firm believer that in this day and age, since this is a formula, all of us can instantly get on our cell phone if we want, anytime we have a Wi-Fi connection or a cellular connection. Heck, maybe you don't need to have it memorized. So what I suggest is you take that index card I gave you earlier in the period, Side note, if I forgot to give you an index card earlier in the period, remind me to give you an index card at this point. Take that index card I gave you. You may write this formula down on that index card and use it on the quiz and the test next week. Well, sorry, this week. See, I'm speaking from Friday. You guys are at Monday. All right? I'm not so worried about your ability to memorize a formula as I am about your ability to use that formula. And that really should be the focus of this class anyways. All right? I wrote A here. I probably should have written the number 2 because that was A's value. Just notice that right there. All right? Now let's resolve this. That's the same as negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 2 is 8 times 4 is 32 all over 4. Okay? That's the same as negative 3 plus or minus the square root of 9 take away 32. That's going to get us well into the negatives. It's going to get us 23 into the negatives all over 4. Oh, I'm off the screen there. All over 4 still. Last step is to resolve this radical. 23 is a prime number, so nobody's coming out except this whole negative business. We can't leave a negative inside a radical, so our final answer is going to be negative 3 plus or minus. Oh, bells. Gotta love bells. Maybe we could start singing the formula to the bell. Negative b plus or minus square root. No, we'd have to do it too many times to get through it. Anyways, told you I was amped on caffeine. Anyways, that's going to give us, if this comes out to right there, an I on the outside. So negative 3 plus or minus I square roots of 23 over 4. Now, I know on that program that generates your worksheets, they would write your final answer as negative 3/4 plus or minus I square roots of 23 over 4, but that's kind of silly to me. You have a denominator. Leave your term like this. That's the best answer in my book. All right. Hope you enjoyed. That is how you apply the quadratic formula. Again, if you haven't, or if you're just interested, in general, watch my quadratic proof video. It's mind-blowing, if I do say so myself. Actually, I'm just assuming that it's mind-blowing because I haven't recorded it yet. It's what I'm about to do in a couple minutes, but I'm going to anticipate that it's mind-blowing. Also, look for the video in which I demonstrate how to do problems number 6 and 15 on your homework. Till next time.